Hello and welcome to Part 4A preview assignment. Okay. As these will be two parts. Part 1 will be going through the tutorial and Part 2 will be going through the questions. And today we're going to be based on more statistical work. So let's get started. What are the risks? Let's see, complex numerical summaries, graphical displays, lesson 4. Okay, part A. In this tutorial, we'll be going over reading values from a table, writing a percent as a fraction or decimal, and writing a probability statement as a 1 in some number chance. So let's continue. Reading on, in the next class, we'll work with data from 2010, 2012, collected by the NCI at this website, and we're using this here spreadsheet, QR underscore spreadsheet underscore for alpha underscore preview. And we'll be pulling this up shortly. In fact, here it is right here. So let's open up the spreadsheet. And size it. Okay, so let's see what we got here. And we're not going to need this, so let's get rid of it. All right. So we have two tabs. One for data for males, one for data for females, and one as a both combined. And they all have similar layout. Basically, it's lifetime risks, risk of being diagnosed, and risk of dying from. Okay. Now, do note to have a risk of dying from it, you had to have had it. Okay. So, say for, let's go with colon and rectum cancer. About just under 5% of males in their lifetime will be diagnosed with colon or rectum cancer. So 5% yes, that means 95% does not get diagnosed with colon and rectum cancer. So there's 1.99% as a risk of dying from cancer. That 1.99% has to come out, has to result from, of the 5% who do get diagnosed with the cancer, of this 5%, only 1.99, just on 2%, would die from it. So let's take a quick look at that. That means, let's go out of 10, which means out of 10,000 males, okay, 5% will be diagnosed with this cancer. Okay, so let's times that by 0.05, which means out of 10,000, that means 500, 10,000 times 0.05. Yes, 500 will be diagnosed. And of that 500, 2% of those 500 may very well die from cancer. With 10 males. So in reality, 10 out of 10,000 may die. So keep these numbers keeping that context, you have the risk of being diagnosed, chances of getting it, and once you get it, you have a chance of dying from it. So these are some pretty important differentiation that needs to be made from this data. Again, in summary, the risk of dying is from having been diagnosed. If you're not diagnosed with it, you can't die from it. So even though it's 2%, it's really a lot less than that. All right. All right, so, and of course, we have a number of different types of cancer being looked at. For men, looks like the biggest hitter is prostate cancer. Females, the same columns. Looks like their biggest hitter is breast cancer. And combined, yeah, let's not worry about that one. All right, so there's a table. Let's get back to the tutorial. Refer to the spreadsheet to answer the following questions. Okay. The risk a U.S. male has of being diagnosed with cancer, all site, is, okay, being diagnosed with cancer. That means any cancer. So let's see, all sites, so referring to this row here. Again, let's say again. Okay, being diagnosed with cancer, all sites. Risk being diagnosed, so there's a column, here's the row. Looks like 42.05%. So let's see. Top row gives total percentage of males who are diagnosed with any type, while the other rows indicate specific types. Okay. 42.05. That's not what I wanted. Next question. Answer the following question. The risk a U.S. male has of dying from cancer is, okay, U.S. male dying from cancer. What cancer? All cancers. So let's see. We'll look at all sites again. Risk from dying. Once diagnosed, okay, you got to be diagnosed first. Risk of dying from it, of cancer is 22.62%. Explanation. Yep. 22.62%. Okay. Percentage of females who will be diagnosed with cancer. Again, all sites. So we need to make sure we're on the female. Remember it said female all. So let's go to female, all sites. So being diagnosed looks like 37.58%. Explanation, second tab on spreadsheet. Yeah. 37.58%. So it's easy to read the tables. Again, the percentage of U.S. females dying from cancer is about what? Well, let's go back to the spreadsheet. Females of cancer of dying. Looks like 19.13. Yep, 19.13. Now it says data can be expressed as a 1 in some number chance. And the example they give is the risk that a male will develop melanoma of the skin during his lifetime is 2.62%. Check that out. Male melanoma, 2.62% risk of being diagnosed. Okay, yes. And how they convert that to 1 in some chance is, okay, well, here's the ratio. So here's the chance, 2.62, or the probability of, the percentage of. We will always use 100 in the numerator. And then all we're going to do is do the math. What is 100 divided by 2.62? Use your calculator, and you'll get 38.1679. And then round to the nearest whole number. So since the 0.1, or 1 is less than 5, we're not going to round up, so that's why we keep it at 38. So 1 in a 38 chance of being diagnosed with kind of skin cancer or melanoma. Or melanoma of the skin. Refer to your answer from question 1, part A. Question 1, part A was 42.05%. Double check that. 42.05%. So to find our chance, let's take 100 divided by 42.05, and we'll find out that that number comes to 2.378, and since 3 is less than 5, we'll say a 1 in 2 chance. Divided by 42.05, 2.378, approximately 2. So a 1 in 2 chance of being diagnosed. So again, we just took the percentage of your chance of getting the said cancer, then divide that into 100, got that number, and then we rounded to the nearest whole number. So let's see, we just did it before, previous section. Figure it was 1 and 2. Oh, gotta read the question. Read the question. Which find closely describes male's risk of dying of cancer? Well, what was that percentage of dying of cancer? Was 22.62. Let's take 100. Find what that is. a 4.4209. Again, less than 5. So 1 in 4 chance of dying of cancer. Now, again, and the last one was 1 in 2 chance of being diagnosed with cancer. This 1 in 4 chance is once you get diagnosed. If you never get diagnosed, you have no chance of dying of it. So 1 in 20, 26.2, 420, about 4. Answer C, 1 in 4 chance. But again, I like to very, very emphasize even though it's 1 in 4 chance of dying from cancer, okay, but you have to be diagnosed with it first. Again, this 22 comes from the population that makes up that 42 number. Next question. Which of the following most closely describes a female's risk of dying of cancer? So, female risk, dying. Let's go to the table. Female, dying, 19.13. So let's take 100 divided by 19.13. 5.227, less than 5. So 1 in 5 chance of dying of cancer once diagnosed. Okay, 19.13, what we got? D, 1 in 5. Okay, now statistics. We talk about probabilities, probably something happening. And really the simplest explanation of probability, simple probability, is it's just a fraction. Thinking at the same time I'm writing. So let's say P of A, the probability of event A. What's event A? Event A is what's the chance of the sun rising in the east? What's the probability of rolling a 1 on a pair of dice? What's the probability of Thanksgiving occurring on December 25th, and so forth? So probability is number of ways event A occurs. Of course, you're rolling a dice that has 3 1s on it. You roll a 6-sided dice with 3 1s. Well, if you roll a dice, how many ways of getting an a 1? 3 times, 3 ways. Number of ways event A occurs over total number of events. Number of events possible. Let's go with the 6-sided fair die. Probability of rolling a 6. Well, let's see. How many ways can you roll a 6? How many 6s are on a 6-sided die? Well, there is only one way a 6 can come up. Well, how many possible events are there when you roll a 6-sided die? Well, there are 6 possible numbers, 1 through 6. So let's go read probability here. In statistics, we examine risk using a method called probability. Okay. So probability is a risk tool. Theoretically, probability can help us understand risks that we face in life, such as the risk of getting a serious disease. Probability expressed as a number between 0 and 1. We can also say 0% and 100%. The probability that an event never occurs or it has zero probability of ever happening is represented with number 0. The probability that it always happens 100% of the time is represented by the number 1. For example, probability of New Year's falling on January 1st. Well, unless they change the rules of holidays, that's 100% probability. Probability of the sun rising in the west. Unless the Earth changes its orbit, the probability of the sun rising in the west is 0. Usually it's not those kind of definitive. There's usually some number in between. A couple of examples given below in which a 6-sided die is rolled one time. Note the plural of die is dice. Okay. If die is probably made or fair, the 6 possible outcomes for one roll, 1, 2, 3, 4, 5, or 6, are equally likely. And again, a simple example, and then of course, probability rolling is 7. Of course, I can roll the dice, and how many 7s are on the die? None. If I roll a die, how many possible events are there, or outcomes? 6. 0. So you want to read this once or twice. And when you go through this on your own, go through and take your little self-test here. In my case, how confident am I that I can read a table, a value from a table? Pretty confident. How confident that you can write a percent as a fraction and decimal? Pretty confident. How confident you can write a probability statement as a 1 in whatever chance? Pretty confident. Okay. So with that, if you need to, you should be done with this tutorial. Go off and do the next video, which will be over the questions. So with that, I'll see you shortly.